Hello everybody, welcome back to the training of the M172. In this part of the model, we're going to start programming our controller. We're going to start with an exercise, and in that exercise, we're going to create a project, we're going to generate some POUs, okay, program and function block, and define some variables. So let's start with the project. In this exercise, what I want to do is to recreate this control. So we have the status of an actuator and the temperature. So if we want to replicate this thermostat cycle, when we read the analog input in the controller to read the temperature, when that temperature is higher than the set point plus the delta, the actuator is going to be in on. When the temperature is lower than the set point, the actuator is going to be in off. So what we're going to do is to put this control into the controller. This is another view of the problem that we have. If we are in the actuator in off, the only way to go to on must be when the temperature is higher than the temperature set point plus the delta. And the only way to turn off the actuator will be when the temperature is lower than the set point. So these are the steps to follow in this exercise. So we need to start by creating the project. So let me just open the application. Okay. Let's open the HVAC installer. I'm going to define this controller, the one that we have in our demo cases. And then what I'm going to do is to save this project. So I already have the training folder. I'm going to set another training folder. And this is going to be machine. See, the type is CFN. We already saved this. Now I need to create the instance only for the Machine Expert HVAC controller. I'm going to name this as PRG PLC. I forgot to change this. Underscore PLC. Okay. It's going to create the instance of the EcoStruxure Machine Expert. Okay. So now we have already created the project and defined the controller that we're going to use. So let's proceed with the presentation. Yep. So far so good. Now what I want you to do is to configure the BIOS parameter. In this case, what we're going to do is to configure the analog input to read the temperature sensor, which is connected into the analog input number 1. But in this controller, we need to configure a spare. So analog input 1 and 2 must be for NTC in this case. In this example project, we are also going to work with the temperature sensor over Modbus. So this configuration must be activated. Then they can open to communicate with the expansion module. And then what we need to do is to configure the IP address of the equipment, and finally the Modbus parameter to communicate with the display. So let's proceed with this. It's gonna take some time, okay? But you can do it with me. So let's open the machine, BIOS parameters. So we have this, even if it's default, I'm going to configure anyway. So here, RS4852. So this one should be 1, number 3 for Modbus RTU, data byte 8, 1, 2 for even. Okay, that's good. Everything good so far. Now this one, I'm going to change this. I'm going to leave this as 1 and the same baud rate. Now, what we need to configure, this is for the communication modules. We don't want that yet. I want to configure the IP address of the equipment, something that I use usually for this controller. Default gateway. Good. And now what we need to do is to configure the Modbus communication for the display. So number 3 for Modbus 8, 1 even, and number 2. Okay, so the initial configuration of the communication is complete. So let's proceed with the presentation. Now, we need to create a program that's going to make the logic. So let's start with this. So far we have configured this. I'm going to save the project and go to programming. In the programming, we need to add a POU as a pole of program. I'm going to use, in this example, function block. I'm going to call this thermostat. I'm going to call this in the time. Okay. Good. Now we're going to create a new function block, okay, which is different from the previous one that was program. In this function block, we're going to create the logic that makes the changes of the states of the thermostat. So go back to the program, add function block. In this case, I'm going to use a structure test so you can get familiar with all the language. Again, I need to change this to English. There we go. Hysteresis. There we go. I'm going to save this. Perfect. We have already created the thermostat, the POU, the P in there, and then the function block FB in there. As you can see, the only block that is called is the thermostat because it's the program. Now, what I want you to do is to copy this code, okay, and put it into the function block that we already created. So what I'm gonna do, because I don't want to copy everything again, I have this ready in a different file. I'm gonna copy, okay, see the code, and now I'm gonna change this view to copy the digital inputs. Copy and paste. Now I can change the view to gray. Okay. So there's a few important things here. If I want more inputs in the function blocks, I just need to click here, the class, and change for input. And if I want more outputs, I just click in outputs. And then I can define the pin of the function block. I'm going to delete that. Now, there are some important things here. For example, if I want to start the code, instead of typing, okay, if our temperature and make mistakes like I did, it's much better to just drag and drop into the code. So we avoid any mistakes. So as you can see here in this example, we have the condition if, and we analyze if the temperature, the input, the temperature is higher than the set point plus the differentiation, the delta, the output must be true. But if the temperature is lower than the set point, the output will be in false. It is important that the assignation is this, colon and equal, and each sentence must be ended with a semicolon. Now, in this controller, when we disconnect the sensor, we receive this value. But in this case, this input is real. So we're going to see something very different from this to analyze. So we make these changes in the software. Now, let's go to the presentation. This I told you, you can drag and drop the variables to avoid mistakes. Now we have already defined the function block. Now it's time to link the real world with the PLC, and that is only possible via the configuration. So we need to go to our program. Okay, we're gonna save this. Serial warnings. We need to go to configuration, local. I'm gonna name the analog input 1 I underscore proof and DO1 DO for cooling. This would be the actuator output, and this is for alarms. Good. Now we have linked the serial word with our PLC. Let's save this. Continue with this. So now there is some important information that we need to create in the PLC. There are some variables related to the configurations. We need to make this in the application. We need to make this logic. Okay, so far what we have done is to create a variable that will be linked to this actual temperature, but we need to define these variables. Okay, it can be a constant, but in this project we're going to create a variable to that. So I'm going to create RCFG underscore temperature set point. I'm going to create another one for minimum value and max. And I'm going to create another one for hysteresis. Now, I had defined this as a real, so I need to use real here. Okay. Follow me in this process. Everything real. So I'm gonna make some default values. 0, the maximum value will be 30, 15, that's 0, and that's 0. So I'm gonna link now this to the minimum value, the max value. Okay, I'm gonna assign this as centimeters. Okay, good. I need this format. We can also make some comments here. Okay, so we're gonna save this. As you can see here, we have an error. And what is the error for? We have an overlapping because the real has two words, and here we have defined this space for this variable and this. Okay, so the easy way would be to select everything and recalc. So it changed the address, and now we don't have any overlapping. There we go, perfect. So we have created the EEPROM parameters for the configuration. And now we need to go to the status. Let's create those variables in there. So something important is the limit of this. We have a limitation in the range. This is the range for this unit. Okay, this value. So let's go to status and create a real R indication temp amp. It's gonna set real format. Now I'm gonna create a boolean for indication of the alarm. Boolean. Good. We also have a limitation in the value here, which is different from the EEPROM parameters. So let's delete this variable and continue with the project. So we must be careful in the way that we address the variables to not create any overlapping. So this is something important. Now that we have created the EEPROM parameters, the IO mappings, and the status, we are able to see that in the programming. So let me show you this way. So let's compile everything. Okay, 0 errors, everything is safe. And now if we go to the programming, here in aux variables, we can go to global share and see EEPROM parameters, IO mapping, and status. The status are the one that we last created, the IO mapping to connect to the reality, okay, for temperature sensor, for the alarm indication, and for the cooling the actuator. And then we have the EEPROM parameters. So far so good. And let's continue with the presentation. This is something important. Drag and drop is in everywhere here. So it would be much better instead of typing if we just drag and drop. So we have already created the function block that will make the logic. And now we need to call that. And the way to call it is using the function block. So I'm going to drag and drop the function block here and use instance underscore FB hysteresis. Okay, good. This is our function block that we have created. If you can see here in the thermostat is called this variable. So let's compile everything again. Good. Here we can see the variables. And now we need to map this information here. Okay. What we want to create is this, and this. So let's do this. Go back again. So the temperature. This is the configuration. So it will be the this one. I'll explain later what I want to do. This function block. Okay. The set point. This is the send point, and I want it to be input. Good. And then the differentiation. Differentiation is the star says input. Now, for alarm, I have the this indication. Okay, output, and the cooling one, I'm going to use this one. Okay, good. Now, if I want to do this in the same run as this one, it's not allowed. So we need to use another network. I'm going to cancel this. Okay, I'm going to show you the network. View, toolbars, network, this. So I'm going to insert in top. Okay, I had done this option. I'm going to use the analog input. I'm going to use to real. I'm going to change that information because it's integer and I need a real value. Operators blocks, conversion to real. I'm going to click. I can add like this, but I'm going to show you another way. Right click, connection mode, click and click. Now I change the value. Now I need to divide this by 10. Logic, arithmetic, div for division, drag and drop again. I'm gonna connect this output. I'm gonna use a constant value, okay, and divided by 10. But the previous value, this one is real, so I need to use 10.0. Okay. And now I'm gonna connect this point to this point, just like this. Output. So I want to explain a little bit more why I need to divide this by 10. So the analog input, I prove if the temperature, the external temperature is 22.6 grades, the analog input will read this value. So in order to process, we need to divide that. But if we don't use the real and divide directly by 10, we're going to lose this part, the 6. That's why I need to convert first to a real value and then divide. Okay, it's much better in that way. So let's continue with the project, the presentation. Now, this one is good. When do we know when there is input and output? Well, it's easy. Input, if this value is going to be the input for a function block, and it's going to be output if it's the output of the function block. Okay, simple as that. If you have any further question, just contact us, okay, at the service team or to me directly.